Hey there and welcome. Today, we are going to unlock the secrets of one of geometry's most fundamental and perfect shapes, the circle. You see them everywhere, from the tires on your car to the pizza on your plate. But have you ever really stopped to think about it? How do you measure something with no corners, no straight sides at all? Well, let's dive in and find out. So, here's what we've got on tap. We're going to start with the basics, the anatomy of a circle. Then we'll figure out how to measure the outside, that's the circumference, and then the space inside, that's the area. After that, we'll put it all together and tackle a real problem. And to finish things off, I'm going to leave you with a challenge to try yourself. Okay, first things first. Before we jump into any calculations, we've got to know what we're actually working with, right? So let's break down the basic parts of a circle. I promise, getting this foundation right makes everything else so much easier. Okay, I know this might look a little complicated, maybe a bit dense, but don't worry. All this information really just boils down to a few key ideas, and these ideas define every single circle out there. Doesn't matter if it's the size of a dime or the size of a planet. So let's break it all down. Okay, so that definition sounds super formal, right? The set of points in a plane. What does that even mean? Well, think about it like this. Imagine you've got a tetherball pole in a yard. If you take that rope and walk in a perfect circle, keeping the rope tight the whole time, the path you make on the ground, that's a circle. The pole is that fixed point in the middle, and the rope, that's your fixed distance. So let's put some official names on these parts from our little story. That pole right in the middle, that's the center. Easy enough. The length of that rope, from the pole to where you're walking, that's the radius. And if you were to draw a line from one side of your path, straight through the pole to the other side, well, that line is the diameter. Now this right here, this is probably the most important relationship you need to remember. It's super simple, but absolutely crucial. The diameter is always, and I mean always, exactly twice the radius. It's a perfect 2-to-1 deal. So if you know the radius, you automatically know the diameter. This little rule, D equals 2R, is seriously the first key to unlocking everything about a circle. All right, so we've got the basic anatomy down. Now we're ready for the fun stuff, the measuring. We're going to start on the outside of the circle and figure out how to calculate its total length. For circles, we have a special name for that, the circumference. And to do that, we're going to need some help from, well, probably the most famous number in all of math. You've definitely heard of it. It's what we call an irrational number, which is just a fancy way of saying its decimal points go on forever and ever without repeating. For what we're doing today, we're just going to use its most famous nickname, 3.14. And that number is, of course, pi. You knew it was coming, right? So what is pi, really? Well, it represents this amazing, fundamental truth about every single circle in the universe. If you take the distance around a circle, the circumference, and you divide it by the distance across it, the diameter, you will always get pi. It's this incredible universal constant, kind of like a secret code that connects a circle's width to its length. And because of that amazing relationship, we get our first super powerful formula. To find the circumference, all you have to do is multiply its diameter by pi. Simple as that. And hey, remember how the diameter is just 2 times the radius? Well, that means you can also find the circumference by doing 2 times pi times the radius. Both formulas work perfectly. Okay, let's actually try this out. Let's say we've got a circle with a diameter of 32 centimeters. So what do? First, grab the formula. C equals pi times d. Next, just plug in the numbers we know. So that's C equals 3.14 times 32. You crunch the numbers, and boom, you get a circumference of about 100.5 centimeters. See? Not so bad, right? Awesome. So we've totally got the outside edge figured out. Now, let's switch gears and move inside the circle. How much space does a circle actually take up? The flat surface inside the line? In other words, what's its area? And guess what? To find the area, our old friend pi shows up again. But this time, the formula is all about the radius. The area of a circle is pi times the radius squared. And don't let the squared part trip you up. All r squared means is you take the radius and multiply it by itself. That's it. So let's run through another example. This time, we've got a circle with a radius of 9.2 centimeters. Step 1, grab the formula. A equals pi r squared. Step 2, plug in what we know. So that's going to be 3.14 times 9.2 times 9.2. Do the math, and we get an area of about 265.9 square centimeters. And hey, notice the units. They're squared now, because we're measuring area, not just length. Okay, so we've got the formulas for circumference and area down. Now for the really cool part. Let's use what we know to solve a problem that's a little trickier, where a circle is just one part of a bigger shape. So check this out. We've got this shape right here. It's a perfect quarter of a circle, like a slice of pie, right? And our job is to find two things: the perimeter, so the distance all the way around the edge, and the area that this colored part covers. So how would we even start this? Let's tackle the perimeter first. Okay, so that curved part, well, that's just 1/4 of a full circle circumference, right? The math gives us 33 centimeters just for that curved bit. But wait, we're not done. The perimeter is the total distance around. We can't forget those two straight sides. And since this is a slice from the center, both of those sides are just the radius. So we add 21 plus another 21 to our curved piece, giving us a grand total of 75 centimeters for the perimeter. Okay, now for the area. The logic is exactly the same, which is pretty cool. We just need to find the area of the full circle first, and then, you guessed it, just take 1/4 of that number. So we use our trusty area formula, pi r squared, do the calculation, divide by 4, and we find out the area of this slice is 346.5 square centimeters. Wow, okay, we've come a long way. We started with just the basic parts of a circle, and now we're solving for these more complex shapes. We've defined all the key terms, we've used the formulas, so now I think it's your turn to put all this knowledge into action. All right, here is your challenge problem. Your mission, should you choose to accept it, is this. Find the circumference of a circle when you know its radius is 2.6 centimeters. So take a second, think about what information you've been given and what formula you'll need. Look, the most important part of solving any of these problems is just knowing where to start. And now you've got the tools. You know the formulas. You know the relationship between the radius, the diameter, and the circumference. So what's your first move? How would you begin to solve this? Figuring that out, that's the real key to unlocking any problem with a circle.